All right, functions class. This is the warm-up that we started with on Thursday and Friday. So if you could go ahead and hit pause and do these questions. I have given the answers, but I would really like it if you tried to do it on your own. Okay, we are starting a new topic. It's called scalar multiplication in matrices. I would like you to write a title. You don't need to start a new page. You can just write it in the middle or wherever we ended. I would like you to put the highlighted part. So in Algebra 2, we did see things like this, and when we saw that, we would distribute this 2 to both things inside the parentheses. So then we would get 14x minus 6. We're going to use that same idea with matrices. So a scalar is something, is like a fancy way of saying a constant. So we are going to multiply any matrix by any constant, and we're going to do some examples to show that. Okay, so here is an example. A scalar is multiplying by a constant. The matrix will stay the same size, so when we're just multiplying by a scalar, we'll just keep it the same size. So this is saying find 3a. So 3 is the scalar, a is the name of the matrix. And what we're going to do is take that same idea of distributing that 3 to every entry in the matrix. So I have done that here. I've done 3 times 2, 3 times 2, 3 times 4, 3 times negative 3, and we're going to do that. So what we're going to do is we're going to write 3a so the reader knows that I am multiplying 3 to every entry in a. So that is your answer. So a scalar can be a number that is less than 1 but greater than 0. It can also be negative. It can be any real number. So the scalar on this one is 3/4. And we're going to multiply all the entries by the scalar. So we're going to do the same thing we did before. So we're going to multiply every entry by 3/4. And when I do that, I get that. So this would be your answer. And all the entries are smaller because we multiplied by a number that is greater than 0, but then less than 1. If that had said like 5/4, our numbers would have been bigger, like they were on the page before. When we multiplied by 3, all the numbers tripled in size. All right, so now we're going to do another topic. We're going to find the sums and differences with matrices. That's adding and subtracting. And the biggest thing that we need to remember, and the thing that we need to ask ourselves first when adding and subtracting, is that they have to be the same size. So the dimensions need to be the same. So the dimensions of all of these, I wrote them out so that I would know what they were right away, so I know what I can add or subtract before starting all the work, because I don't want to do any work that I need to repeat. So to add and subtract, what you're going to want to do, so we're going to kind of go through this slowly. We write down the matrix. So this is W. I put an addition sign. This is Y equals, and for some reason I didn't erase this. So I need to wipe. I think I made a mistake here when I was doing the lesson. So what we're going to do is 3 plus 1. So whatever is in the same address in the matrices, we're going to add those numbers together and get a new number. So we get 3 plus 1 is 4. Negative 2 plus 4 is 2. 1 plus negative 2 is negative 1. And 0 plus 3 is 3. So we did that. We did check to see that they were both 2 by 2s, which they are. We also, when we started with 2 by 2s, we ended with a 2 by 2. So our answer is also a 2 by 2. To do x and y, this is not possible. This cannot be done because you cannot add a 2 by 3 and a 2 by 2. So something on the test I would write not possible. Okay, so now we're going to do the same thing but with subtraction. So we're going to do y minus w. So the first thing we have to do, they are the same size, they're both 2 by 2, so we can do this. So I write them in the exact same order that I am given, y. So I have this matrix is y minus this matrix. Now, you have to, here we go. You have to distribute a negative 1. So we have seen things like this before. In Algebra 2, we would see something like 2x plus 3 minus 4x minus 3. Something like that. before we could start combining our like terms or do anything, we would need to distribute this little pretend -1, it's like an invisible one, and we would actually end up with 2x plus 3, -1 times 4x is minus 4x, -1 times -3 is actually a positive 3. Then we can combine our like terms and go about our way. So what we would do to w's, we are going to distribute that -1 to all of that, so that I can do that, and then I'm going to change it into an addition problem right there. So this is now this. And we know how to do addition because we just learned on the slide before. So then 1 plus -3 is -2, 4 plus 2 is 6, -2 plus -1 is -3, and 3 plus 0 is 3. So we are going to do that every time. So make sure you distribute the -1 to matrix W. Once that's done, you can add. So the one thing that students miss most often is changing that to an addition problem when they're done.